Hi there. So in this video, we're going to look at setting up and solving inequalities as well as writing our solutions in interval notation. So with equations, whenever we were solving equations, we had a single answer or we had our special cases of infilling many solutions or no solution. When we solve inequalities, inequalities will give you a range of solutions, so any number greater than or less than a particular number, or even for a compound inequality between two numbers, for example. Um, your symbols, I'm going to scoot on down below example 1 and just draw your attention to this box on the middle of the page. Your symbols for inequalities are less than and greater than in the top box, less than or equal to, greater than or equal to in the middle box. And then we'll be picking up a term just below that. It's positive and negative infinity for our interval notation here in just a few moments. But we'll start back up here in example 1 in letter A, and just write a basic inequality. When you write inequalities, your letter is going to be on the left, followed by your inequality sign, and then the number, okay? So here it says, let x be the weight of a dog, and they want us to write an inequality just to express that a flea medication is for dogs weighing over 100 pounds. So x is the weight of our dog. Sorry, let me get my pen here. And the dog has to weigh over 100 pounds, so over means greater than 100. That's all that we're looking for there. All right, we move on. If you want to try B on your own, just pause the video. Otherwise, I'm going to go ahead and do B here. It says here, let x be your speed. Write an inequality to show that your speed should not exceed your posted speed limit of 55 miles per hour. So that means then your speed should be less than or equal to 55. Okay, so you write an inequality, like I said, a letter on the left, inequality symbol followed by the number. Okay, that's your basic form of an inequality. And that means then any number less than or equal to 55 is a valid speed. As long as, we're talking about speed, so as long as it's a positive number. And then over here, that flea medication is for good for any dog weighing over 100 pounds. Okay. All right, so now let's introduce this idea of interval notation, because that's ultimately how we're going to write our solutions for inequalities. So less than and greater than will always get soft parentheses when it comes to interval notation. Less than or equal to and greater than or equal to are going to get hard brackets. And infinity is always going to get the soft parentheses as well, because you can't cut off infinity, okay? Because think about Buzz Lightyear, infinity and beyond. It just keeps on going, so you can never cut it off, so it gets a soft parenthesis. All right, so now down below, what I've looked at is just a visual representation of these inequalities. So like for the first one, I said, let's graph x is greater than 2. Okay, so remember, you think of this then as any number greater than 2. So I've got my 2 here on the number line. Since it's the greater than symbol, we used a soft parenthesis. And then as long as your letter's on the left, I'll give you a trick for this. As long as your letter's on the left, your inequality sign here is pointing to the right, so we shaded to the right, okay? Now, if we're going to write this now in interval notation, this graph starts at 2, and then it goes to the right forever, so hopefully you agree here with me, then that's going to be positive infinity. Infinities always get parentheses, and because that's greater than, it also gets a parenthesis, okay? Let's look down at the example down below that. Now let's look at graphing x greater than or equal to 2. So greater than or equal to indicates that we can equal that number, so we're going to put a hard bracket at the 2. My letter's on the left, my inequality sign then is pointing to the right, so I can shade to the right. If I write this now in interval notation, this graph is starting at 2, and then it is going to the right again forever, so that's positive infinity. Infinity always gets a parenthesis, but this time, since we were able to equal the 2, that 2 is getting a hard bracket. Okay. Now, I know my graph isn't showing this here, but there shouldn't be a space there. It is coming up and right equaling that 2. Okay. There's not a gap there. If you ever need to graph an inequality and your letter is not on the left, I always recommend that we put it so that our letter is on the left. If you have to rewrite it so your letter's on the left, you're going to end up flipping the inequality sign. You'll see that play out in the next page, okay? So let's flip it on over. In example 2, I say if the variable is not on the left-hand side, rewrite it so the variable is on the left-hand side. We're going to graph it on the number line using our appropriate symbols, either brackets or parentheses, and then we're going to write our answer in interval notation. Okay, so in letter A here, I'm going to do A and B with you and let you pause the video and try C on your own. In letter A here, I'm looking for x values less than -3. So my letter's already on the left, so I'm ready to go to my number line. What I normally do is I just put a 0 in the center, -3, put it over here on the left. I'm going to use a parenthesis or a bracket. And then hopefully you agree here. I'm going to use a different color. I'm going to use a parenthesis since it's just less than. This inequality sign is pointing to the left, so I am shading to the left. And that is my final answer there in terms of my graphing. Now let's write our interval notation here. This graph is coming in from the left, so it's coming in from what kind of infinity? Negative infinity, and then it stops at -3. Infinities always get parentheses, and then that 3 we already know gets a parenthesis. -3 gets a parenthesis. All right, let's move over to B. In letter B here, my letter is not on the left, so I'm going to rewrite it so that my letter is on the left. Here, the inequality sign is eating the x. When I rewrite it, it still needs to be eating the x. Okay, so that's what I mean by flipping the inequality sign. All right, so now I'm ready to draw my number line. I always put 0 in the center, so 4 is positive, so it's going to be on the right-hand side. Bracket or parenthesis this time? Hopefully you agree. That's going to be a bracket. If you need help, refer back to the table on the previous page. Less than and greater than get parentheses. If you have a line underneath your inequality sign, it gets a bracket. This inequality sign is pointing to the right, so I'm going to be shading to the right. So I am putting a bracket at that 4, and I am shading to the right. So now if I write my interval notation here, this graph starts at 4 and goes to the right forever, so that's positive infinity. That 4 is going to get a bracket. That would be my final answer. Okay, and like I said, pause the video and try C on your own. Check yourself by the solution key. All right. Whenever we solve inequalities, we're going to be solving them the same way that we solved equations. Going to get letters on one side, numbers on the other. Okay. There is one caveat, though, that we do need to take into account, that anytime you multiply or divide by a negative number, you have to switch your inequality sign. There's 2 times that we're going to be changing our inequality sign. Anytime we multiply or divide by a negative number, or if the inequality itself is backwards, meaning you always want letter on the left. So if the letter's not on the left, you want to rewrite it so that it is, and that's going to also require you to change your inequality sign. So for example, down here below, if I say 3 is greater than x, well, that's backwards. I want my x on the left-hand side. So if 3 is greater than x, then x will be less than 3. In other words here, the inequality sign is eating the 3, so when I rewrote it, it was still eating the 3. Okay. All right, so now let's come on down to example 3, and I'm going to do the right-hand column here with you, and then let you pause the video and try the left-hand column. Okay. What it wants us to do here is to solve these inequalities. I'm going to give you the picture. If you don't need the picture and you can go directly from the solve to the interval notation, go for it. But I like to give people visuals as well. All right, so we're solving it. I'm going to graph it, and then I'm going to write my final answer in interval notation. All right, so in letter B here, if I'm going to solve this, I want to get closer and closer to getting that P all by itself. You could multiply by the common denominator if you wanted to, since you've got a fraction, or since it's only one fraction, you could just move towards getting that letter all by itself. So that's the way I'm going to tackle this one. I am going to bring that 6 over. Cancels out. That leaves me with P over 4 is less than, what's that, -8? Last step, I want to get P all by itself, so to undo that division, multiply. I multiply, I mean, my final answer is going to be negative, but I multiply by a positive 4, so the inequality sign stays the same. -8 times 4 gives me a -32. All right, so now I'm going to come over here. I'm going to draw myself a little number line. Here's my -32. -32 is going to get a parenthesis or a bracket. Hopefully you agree. It's going to get a parenthesis, and that inequality sign is pointing to the left, so I am shading to the left. So now let's write that in interval notation. This graph comes in from what kind of infinity? Negative infinity, and stops at -32, parentheses on both. Final answer. Okay. Let's move on down to D. Like I said, I'm do the right-hand column here. Take that -8 and distribute it through first. So -8 times P, -8 times 4. Okay, my goal is to solve for P. Right now that -36 is over there all by itself. Let's take the 32 over to join it. You're crossing that inequality sign, so do the opposite. So add. So -8P less than or equal to, what's that, -4? Last step, I want to get p all by itself. This is negative 8 times p, so to undo multiplication, divide. So I'm going to divide both sides by negative 8. You're dividing by a negative. I'll emphasize this, so anytime you multiply or divide by a negative, switch that inequality sign. A negative over a negative reduces and becomes a positive. 4/8 can be reduced and become a positive 1/2. So there's my solve, p greater than or equal to 1/2. Let's get you a picture. So 0, 1/2 is positive, so I'll put it on the right-hand side here. Bracket or parenthesis? Since it's equal to, I'm going to get a bracket. This inequality sign is pointing to the right, so I get to shade to the right. So now if I write my interval notation, this graph starts at 1/2 and goes to the right forever. Bracket, parenthesis. Final answer for my interval notation. All right. And then let's look at letter F here. Letter F has more than one fraction in it, so I want to multiply by that common denominator to get rid of the fraction. So I want a number that 5 and 2 will both go into. If we agree here, they'll both go into 10. So remember, take that number, divide it by the bottom. Whatever answer I get, I'm going to multiply it up top. So 10 divided by 5 is 2. 2 times negative 3, negative 6x. 10 times 2. The next one, 10 divided by 2 is 5. 5 times 1 is 5. All right, let's get letters on one side, numbers on the other. This 5's already all by itself, so let's bring the 20 over to join it. Do the opposite, so subtract 20 from both sides. Negative 6x is less than negative 15. Divide by negative 6 on both sides. You're dividing by a negative. Divide by a negative. Got to change that inequality sign. A negative over a negative gives you a positive. I can divide both of those by 3. So 15 divided by 3 is 5. 6 divided by 3 is going to give me 2. So x is greater than 5/2. There's my solve. Let's get a picture here. So here's my 0. 5/2 is positive. So I put it over here on the right. Hopefully you agree. I'm going to put a parenthesis. I'm pointing to the right, so I am shading to the right. And so now my graph starts at 5/2, and I'm going to the right forever. So 5/2 to infinity, parentheses on both. Final answer. Okay. If you flip it over, I definitely encourage you to finish up that entire example 3 there, and the 2 on the next page give you more practice with clearing those fractions, okay? And check yourself by the solution key. All right, let's come on down to example 4, and let's solve compound inequalities. With this one, I'm going to do the right side. I'm going to do letter A and B here with you, okay? Whenever you are solving a compound inequality, and especially whenever it's like letter A here, you can see that this 3x is between two numbers. Your goal is to get that x in the center all by itself. So if I'm trying to get that x all by itself, then I want to treat it like a normal equation. So this is 3 times x. So to undo that multiplication, divide. But whatever you do to the middle, you've got to do to the right and to the left. You got to do it to all 3 parts. So it cancels out in the center, and now it's saying that x is between negative 12 divided by 3 to negative 4. 18 divided by 3 will give you 6. So what it's telling you now is that x is between negative 4 and 6. These are usually a pretty easy graph. I've got my 0 in the center. Here's my negative 4. There's a 6. Negative 4 is going to get a bracket or parenthesis, you think? Hopefully you agree. It's right here beside the less than or equal to, so it's going to get a bracket. 6 is right beside a less than sign, so it's going to get a parenthesis. These problems it's saying the x is between these, so the shading is always going to be between the two numbers from smallest to largest. Okay, and then writing in an interval notation, the graphing itself starts at negative 4 and goes and stops at 6, bracket, parenthesis. That's our final answer there for interval notation. All right, and we'll scoot on down. Let's do C here together. C is another example of a compound inequality. B will be exactly like the one we just did there. You want to get closer and closer to getting that x all by itself. Okay. In letter C here, this is another compound inequality. It's just separated by the word or. So what that means is we'll solve the inequality on the left, get an answer, solve the inequality on the right, get another answer, and graph them on the number line. So divide by 2 on both sides here. X is less than -4. I divided by +2, so I have to change the inequality sign. One step here to get x all by itself. Subtract 3. Cancels out, so x is greater than or equal to 4. All right, so I'm going to give myself a number line here. Put my 0. I'm going to have a +4 and a -4. So at -4, I'm going to have a parenthesis. I am shading, I'm sorry, I'm pointing to the left, so I am shading to the left. At +4, I've got a less greater than or equal to, so I am a bracket here. I am pointing to the right, so I am shading to the right. That's shaded in there. So now when I go to write my interval notation, it will look just a little slightly different from what you've seen so far. You've got two legs of the graph here. You've got this portion of the graph and you got that portion that we need to account for in interval notation. So this portion of the graph is coming in from what kind of infinity? Do you agree with negative infinity? And then it stops at -4, parenthesis on both. Then we use the union symbol, just a little u there. We say unite that with, okay, now the right-hand side of the graph. So then the graphing picks back up at +4 and goes to the right forever, so that's positive infinity. The 4's got a bracket, and infinities always get parentheses. Final answer. Okay. All right, I hope this helps. That concludes inequalities. Thanks a lot. Bye.